Hi friends, how are you all? So now we have already completed the introductory portion of sets, right? In this lecture we will deal about set operations. Whenever you do any operation, you will be familiar with four operations. What are those? Addition, subtraction, multiplication and division, right? What do we see in these operations? Yes, the important point is that at least two numbers will be involved when you are doing an operation. Similarly, in sets, at least two sets should be involved. But there is no condition that more than two sets should not be involved. Okay. So, the basic characteristics are the two sets should be involved. Not necessarily fully distinct. Okay. I'll tell you why. Okay. But if you are doing 1 plus 1, you can do 1 plus 1, there is nothing wrong. But what will happen? 1 into 1, you can do, nothing is wrong. But 1 plus 2 can also be done, right? So, it is not necessary that the set should be distinct or identical. It can be anything. Only thing, the two things should be sets. And they should conform to the definition we have studied in our last class. Okay, first, let me tell you the function of or operation of union. Now, before I go to the five operation, let me define two sets. I am defining two sets. Let me define a set A, that 1, 3, 6, 9, 11. This is the set A. See, there is no necessary that it should be like that. There should be a specific formula for a set. Nothing. I am listing these elements. They belong to the set A. Okay. If you are telling me to write this in set builder form, it might be a little bit difficult. But again, we can find some formula, but we are not focusing on that now. Let me define another set B. That is 1, 4, 8, 11. Okay, this is A and this is B. Now, what is union? Definitely, I'll tell you one thing. Whenever you do any operation, the resulting set will have elements, and those elements will not be outside of these two sets. Okay, basically, but there is one operation in which the outside will be there, but let us focus on that later. Now, first of all, let me tell you the notation of union is like this, a mini U. Okay, we write this as A union B. Okay, what is the resulting? This will be a set. This A union B will also be a set. And what will be that set? It will have elements that are present in at least one of these sets A and B. Okay, at least one, any one. Okay, it can be A or it can be B or it can be both. So, let us list out the element. We will list out everything in both sets. Only thing, no repetitions. If an element is there in both, we will write it only once. That's the only thing. Okay, so here 1, 3, 1 is there. Then here 3 is there. Then here 4 is there. Then 6 is there. 8 is there. 8 is there. 9 is there. And 11 is there. This set, it has those elements that are present in at least one of those sets, right? So this is union. Now, the next operation we will do is intersection. And this is the reverse of this union, and its symbol is like this. Okay, and we write A intersection B. And what is the peculiarity of intersection? It will not contain those elements that are in only one set, or it will contain only those elements which are present in both these sets or both these sets. If you are taking three sets, union will contain the those elements which are present in at least one of the three. But intersection will contain only those elements which are present in all the three sets. Here we are taking only two sets, and it will contain only those elements which are present in both these sets. So one is there in both. Okay, one is there in both. 3 is here, but 3 is not here. So 3 will not be an element of A intersection B. 6 is here, but 6 is not here. So it will also not be an element of A intersection B. Now 4 is here, but 4 is not here. So it will not be an element of A intersection B. Now 8 is here, but 8 is not here. So it will not be an element of A intersection B. What about 9? 9 is here, but it is not here. So it will not be an element of A intersection B. 11 is there in both. So it will be an element of A intersection B. 1 and 11. See, are there any common elements? No. No common elements. Okay. This is union and intersection. Okay. Okay. Now, let us define the next complement. You know what this is, complement. For that, to get complement, as you know, we'll have to define U. A universal set is the set of all elements X such that X less than or equal to 12 and X element of N. Okay, X is less than or equal to 10, then it will contain 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's all. So, you know the complement of A. It includes all those elements that are not in A but in U. That is, it includes 1, 3, 6, 9 and 11 from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Similarly, B complement will be 1, 4, 8, 11. Only these elements will not be there. All other elements between 1 and 12 will be there. Okay. So, now let us write A complement. A complement, I have already told you A dash is A complement. So 1 is not there. 2, 3 is here, so 3 will not be an element of A intersection B. 4 is 3 is here, and 4 is not here, so 4 will be an element of A complement. 5 is not here, so 5 will be an element of A complement. 6 is here, so 6 will not be an element of A complement. 7 is not here. 8 is not here. 9 is there, so it will not be an element of A complement. Then 10 is not there, 11 is there, and 12 is not there. So this is A complement. Now B complement. B complement. What is B complement? It will include 1, 4, 8, 11. It will include 2, 3, 5, 7, 9, 10, 12. 2, 3, 5, 7, 5 and let's include 6 also. This is B complement. Now, let us relate this to A union B complement and A intersection B complement. Okay, when you take A union B complement, what will it be? A union B complement will be, it will exclude these things. So it will be A union B, the whole complement will be equal to 1 is not there, so 2, 3, 4 are here, 5, 7, 8, 9 are there, 10 and 12. When you see compare this and these two, you will find that these elements are present in A complement as well as B complement. So A union B, the whole complement, is equal to A complement intersection B complement. Just we are changing the sign outside of the complement. Similarly, A intersection B complement means A intersection B, the whole complement will be equal to A complement union B complement. So this is about complementation, and these two laws are called De Morgan's laws. Okay, that is De Morgan laws. So this is about De Morgan's laws. Okay, so we studied union, intersection, complement, De Morgan's laws. Now, here is there any element like if we are defining some element such that, let's just define some set such I, such that, let us define I and O. What is O? A union O will be equal to A. We have studied additive identity and multiplicative identity, right? Here we can, what we can do is union we can compare or we can relate to addition, and intersection can be related to multiplication. So the element O 0 0 0 will, what the peculiarity of the element 0? Anything plus 0 will be equal to 0. Similarly, in set theory, it is not necessarily to be 0, but if A union O is equal to A, if A union O is equal to A, then that element is called the additive identity. Similarly, if A intersection I is equal to A, okay, A intersection I is equal to, let me tell you, A intersection I is equal to A, then it is called multiplicative identity. It is related to that, but these are not important for us. The thing that are important is the set U and the set phi. What is U? U is the universal set, and phi is the null set, no elements. So, what is the peculiarity of U and N? Let us take A intersection U. And what will be A intersection U? It will naturally be A. U has every element. So A intersection U is equal to A. Any element, any set intersection, the universal set will be the same item. And A union U is equal to U. Simple. U has every element, so any union of its subsets will be equal to the same set. Now, this is it. A intersection phi. Since phi has no elements, actually this will be phi. Similarly, A union phi will be equal to A. These are two identities which you need to remember. Okay. In the next lecture, we will be dealing with an important concept in sets called the Venn diagram. It is very interesting, but we will cover in the next chapter. Next lesson. So first we saw the operation of union, intersection, complementation, De Morgan law, and some identities. So this will be with this lecture. I hope you found it useful. So we'll meet you in the next section. Till then, stay safe. Thank you.